हाय, आई शशि भूषण तिवारी वेलकम यू ऑल। आज के सेशन में हम एक ऐसा क्वेश्चन करने जा रहे हैं जो आप में से कुछ लोगों के लिए आसान होगा, पर मैक्सिमम लोगों के लिए एक सरप्राइजिंग क्वेश्चन हो सकता है। लेट अस हैव अ लुक एट टुडेज क्वेश्चन, जिसके चैप्टर का नाम मैं डिस्क्लोज नहीं कर रहा हूँ, क्योंकि चैप्टर बता दिया तो शायद बहुत सभी के लिए आसान हो जाएगा। चलिए पढ़ते हैं इस क्वेश्चन को। कंसिडर ए कंडक्टिंग रिंग मेड ऑफ ए यूनिफॉर्म थिन वायर वेयर स्मॉल d is the diameter of the wire and capital D is the diameter of the ring. Capital D is much larger than small d. A charge capital Q is placed on the ring and is just sufficient to cause the ring to break apart due to electrostatic repulsion. You place a certain amount of charge Q on the ring, and because of electrostatic repulsion, the ring just breaks. The linear dimension of the system are multiplied by 2. That is, both small d and capital D are doubled. Now, at what value of charge will the new ring break? That is the question. If you have not understood it properly, I am getting out of a screen for a moment. Take the screenshot, read it twice, try to understand it on your own, and try to solve it before you actually look at my solution. This is a question based on dimensions, scaling, basically method of scaling. The question says that there is a ring, and this ring is made up of wire that has diameter small d. That means if you cut the ring here and you open it like this, you straighten it like this, then this diameter is small d and this diameter is capital D. Capital D is large compared to small d. It simply means you need not worry whether this is capital D or this is capital D or here it is capital D. Everything, this one is capital D only. Okay. Now you place a charge, it is a conducting ring, so charge will distribute uniformly, that can be assumed. So charge distributes uniformly on the ring, and because of repulsion, tension develops, and the tension exceeds the, rather I should say, the stress developed exceeds the breaking stress of the material of the ring, and therefore it breaks. So at any section, if you consider a section over here, what is the tension, or what is the tension at section at this location? We need not do the exact calculation actually. One thing is important to realize: because of symmetry, tension has to be same everywhere. That means you consider a cross section over here, then this part of the ring is pulling this part with a force T. Let us write tension as T. Then this part is pulling this part with the same force T. So at every section, the tension is T. Here also it will be T, here also it will be T. This tension force must be proportional to Q square by D square. Do you agree to this statement? You have to. This is key thing to understand. The force, Coulomb force, is given by KQQ by R square between 2 point charges. So when you are writing Coulomb force, you are obviously going to get, this K is basically 1 by 4 pi epsilon naught. So when you are writing this Coulomb force, you are obviously going to get Q into Q, product of two charges, in the numerator, and in the denominator you will definitely have a square of some sort of distance. So in this particular question, the only distance that is meaningful right now is capital D. Small d has no meaning when you are trying to write tension. It is a thin wire, that's all. So small d is the only dimension, only length that is given in the question. So it will be in the denominator square of t, and force is proportional to square of charge. It is basically product of two charges. So the only charge that is known to us is q. The force has to be proportional to q square. That means if you do the exact calculation, which I haven't done, of course, it will be quite tedious. You will get some numerical value over here into q square by t square. That has to be there, because no other length, relevant length is given here, and no other charge is there. So it has to be this much only. So by dimensional analysis, we know that tension will be equal to this much, and the ring will break when the stress developed due to tension exceeds the breaking stress. If it is a steel wire, then steel has a specific value of breaking stress, that if stress exceeds a certain number, it will break. If it is a copper wire, then that breaking strength will be a different number. So this tension can be written as here. If you look into this diagram, there is the cross sectional area, which is naturally pi into d by 2 whole square. If tension here is T, then stress is T upon S, or tension can be written as sigma into S, right? So S is nothing but it is a quantity that is proportional to d square. So that actually solves your problem. The ring breaks only when the stress reaches a particular value. In the question says when charge q was placed on a ring of diameter d, it breaks, which means this force, this into some constant obviously is a force. This force was equal to sigma. Sigma is, or let me write it as sigma naught. It is breaking stress into cross sectional area into d square into some constant. So rather than writing all those constants, you can see that it is better to write this way only, right? That means, what does this expression tell you? This expression tells you that quantity of charge that is required to break the ring is basically proportional to d into d. This is what it tells you. The quantity of charge that is required to break the ring is proportional to d into d. So if this d and this d both are doubled, then definitely the quantity of charge required to break the ring becomes 4 times. So the amount of charge required to break the ring when its diameter is double, when the cross-sectional diameter is also doubled, will be 4 times the value of q that is given in the question. I hope you have understood it. If not, then deliberate upon it for a few more minutes and you will be able to understand this. I am confident about it. See you in the next video.